Hey folks, thank you so much for having me. As Vitaly said, my name is ADDY OSMANI. I'm an engineering manager at Google working on Chrome. And in today's talk, I'd like to help you load and render your pictures as close to perfect as possible. We'll see how far we get. I did write a recent book on image optimization. If you've already checked it out, thank you so much for your support. If not, maybe you'll find it useful. No obligation to check it out, but I think you might get something out of it. We'll try to cover some of the ideas from the book and just the general image compression and image optimization space today. One of the reasons I decided to write this book was because whenever I would try to optimize images, I'd start off as a very optimistic corgi, and I feel like I was drowning in several NPM installs, dependencies, and custom scripts later. And so I thought I'd try to capture at least some of the learnings that I've had over time into this book and into this talk. Now, images have been a pretty key part of the web for decades. Our brains interpret images much faster than they do text. And this is why having really high quality visuals can drive conversions and user engagement. Images are also really important for sharing some of the most insightful content on the web. So I recently discovered that Simu Liu of Shang-Chi and the Legend of the Ten Rings used to model in stock photographs, which is something I wouldn't have discovered if images weren't heavily used in a lot of today's popular social media apps. And there's actually quite a lot of them. I was surprised that, it looked like there was 10 or 15. There's a lot. In fact, there's so many that you could do a complete Avengers movie of your own using these stock images, which was just crazy to me. Now, image optimization is an evolving topic. I personally these days rely heavily on image CDNs and build tools to automate this problem for me, just because it's an effort to get the tooling consistently in place for everybody on your team when it comes to keeping up with best practices. Now, the good news is there's been some really positive major changes in the image landscape over the last year or two. We're now in a place where WEBP is supported in all major browsers. AVIF image decoding is in Chromium, and it's hopefully coming to Firefox soon. Got JPEG XL decoding behind a flag in Chrome. And then we've just seen a whole range of different improvements to image loading landing all over the place. So lazy loading is natively available in a lot of browsers these days. It's in Safari Tech Preview. It's a default now in large ecosystems like WordPress. And your ability to control the loading of images, whether it's via preload, or other loading mechanisms, your ability to limit layout shifts from it, all of these things are now in a slightly better place than they were many years ago. And we'll dive into some more detail about loading later on in this talk. But I mentioned formats at the start of this slide. So you might be asking, WebP, AVIF, why should I care about these new formats? Why are they exciting? Now, before we really dive into formats, let's briefly talk about compression. Now, compression is usually the main task of an image codec, and it's really all about reducing the cost of an image, either for transmission to your end users or for storage purposes. Now, with lossy compression, we ideally want to minimize size by removing data that isn't as noticeable to the human eye. With lossless, we usually try to restore an image to its original form as close as possible. There is a lot less destructive work done there. The file size can be larger, but most of the time on the web, we're dealing with lossy image compression and just trying to get something that looks good enough, whether it's for blog posts or product images and so forth. Now, to really appreciate compression, let's visualize it a little bit and take a look at an example from the Kodak image data set. Now, many sites will use this set of images from Kodak as a standard test suite for compression benchmarking or testing. So I thought it would be a good fit here. So let's take a look at this red barn near an old farm. Now, ideally, we should be producing an image that is visually and perceptually quite similar for each of the formats we're going to be playing around with. The image source here is 700 kilobytes in size. It's a PNG. Now, we're going to begin our quality evaluation of JPEG, WebP, and AVIF using some of the default high-quality output settings of a popular free tool, Scrooge.app, that you can use on each format. And in this case, I've intentionally untuned each of these formats so we can mimic a brand new user's experience with them. So let's imagine you don't really know too much about the configuration for each of these formats. And one of the reasons I really like Squoosh.app is that you can visually compare different formats, and it all works client-side in the browser. All these codecs are kind of ported over to WebAssembly. The app is free, works pretty well. Now, as a reminder, before we dive into my examples, you should generally aim to evaluate the quality, configuration, format, and trade-offs that best suit your needs personally. And if you don't necessarily want to do that, image CDNs do try to automate some of this, but do test things yourself if you can. So let's start off with Moz JPEG. Now, this is looking a little bit softer than the original PNG. The details are a little bit less sharp. Texture has changed a little bit, but overall, if we were embedding this into a blog post, it looks pretty okay. And we have some significant file savings here. The Moz JPEG version is only 53 kilobytes at quality of 75%. We can do a little bit better, however. If we go and take a look at the WEBP, what we notice is this is sharper looking, both on the texture of the roof, some of the detail in the trees, and some of the water. It looks a little bit better. We've got some small file savings in place here. Now this is, again, Q75. When we take a look at AVIF, the idea of quality, that number, it is not equal across all of these formats. It can generally translate to different things. But in the case of AVIF, very similar to the WebP, we are able to get significantly better savings than JPEG. The sky here looks a little bit smoother. There is a little bit of loss of texture using the default, but overall the file size savings are quite large here for something that's lossy. Now, this is under 30 kilobytes. We said that the JPEG was about 50. So there's a range in here that we can play around with. And so if we go back into Squoosh and we start playing around with sharpness settings, with quality settings, we can still end up with an image that maintains a lot of that crisp detail in the roof compared to, the JPEG compared to the original. And it's still relatively small in size. The savings are pretty good. Now, I mentioned this difference between lossy and lossless a little bit earlier. So just for completeness, let's take a quick look at lossless. So in the case of lossless, for both WebP and for AVIF, we're able to save somewhere in the range of 100 to 165 kilobytes compared to the original file size. And we have we have most of that rich detail that's in place here. Generally, I look at lossless as being good for people who need to do image archiving, image storage for longer term, especially for those family moments you want to keep forever. But this is another great example of where Squoosh's ability to compare things can be helpful. Now, we were taking a look at the default quality settings, but that's not going to give you, a really good look at where these formats shine. And so we're going to set ourselves a 20 kilobyte challenge. Now, this is particularly useful if you care about bandwidth and size. So with the 20 kilobyte challenge, we're going to compare a JPEG at 20 kilobyte to a WebP or AVIF at the same target sizes. This will let you know just how much value you can get out of just a 20 kilobyte version of the file. So we start off with this JPEG. Notice how the JPEG has got very visible blocky artifacts in both the sky and the roof. This almost looks like a completely different image. Now, when I say 444 in the text here, all that means is that all the color components have the same sampling rate. So they're not using advanced techniques like chroma subsampling to reduce the resolution for certain types of color signals. Now, if you're really staring at this image and all of these blocks are causing some dizziness, I know what you're thinking. The JPEG compression is just too damn high. And it's true, but let's remember, we're trying to see how much value we can squeeze out of just 20 kilobytes. Now, in case you want to geek out on what are these weird artifacts we're seeing, JPEGs tend to introduce roughly 3 kinds of distortions. There are, first of all, like a loss of color details. Certain apps can aggressively downsample or reduce the resolution of certain color channels. And that's what you see in the very first example here. It can also introduce halos. So a general loss of sharpness and some oscillations around high contrast edges. And then it can introduce some of those blocks that you saw. Now, if that happens if the image is processed separately for each 8x8 block, and those block edges start to become really visible at very high compression ratios. So just something to keep in mind, as you're playing around with JPEG and these different formats. We can also take a look at the WebP. Now, the WebP has got significantly fewer blocky artifacts. Again, this is just a 20 kilobyte image. looks much better details-wise, perhaps not as sharp as it could be on the trees, the textures on the house, or the lines in the sky, but it still looks much better than those blocky artifacts we saw in the JPEG a moment ago. And if we take a look at the AVIF, it's visibly better, in my opinion. It contains even fewer blocky artifacts. It's got sharper, crisper details. There is a little bit of texture loss, again, on the roof and some blurriness. But overall, again, given this is 20 kilobytes in size, it's quite impressive, given the compression factor that you have in place here. And so if you're wondering about, reasoning about the trade-offs for modern image formats, hopefully this slide is useful. So the guidance that I've got here is that AVIF is a pretty solid first choice if lossy, low-fidelity compression is generally acceptable and saving bandwidth is your #1 priority. Now, the team working on AVIF have been putting a lot of time into trying to improve encode and decode times, and so I would play around with it and see if it meets your needs. WEBP is more widely supported right now and is pretty good for rendering regular images if you don't need more advanced features like wide color gamut or text overlays, where it can start to struggle a little bit. I just released a new blog post on Smashing Magazine. It includes a few more details about how to think about these trade-offs. But in general, you do have the ability to use progressive enhancement to deliver really modern formats to people using the picture tag. The browser can choose the first supported format in order of preference. We'll talk a little bit more about that later. And you can also rely on things like accept headers and content negotiation to send out use a single URL, and it will make sure that the browser is able to use the version of an image that it is able to load and render correctly. But we'll talk more about this topic later. Now, when you're deciding on a particular format, whether it's WebP, AVIF, or JPEG, you generally care about a few things related to speed, and I started to touch on that earlier. Now, how quickly you can encode an image into your target format can matter, and how quickly it can be decoded on the end user's machine or the end user's phone can also matter. Now, some folks will say that encode is really important because it can be impacted by CPU, parallelization, can increase your server costs if you're doing it on the fly. And others will say that decode really matters because you can't just do it once and cache it. Generally, it's a cost that every one of your users pay. But think about these trade-offs when you're deciding on formats. The other thing on the topic of speed we're really going to deep dive into is loading. Now, when we're loading images these days, we tend to heavily rely on the image element. And the image element has gained some superpowers over the years. Just think about how many times in the past we'd rely on a JavaScript library for shipping an advanced image loading experience. Browsers are now pretty capable of doing a reasonable job. These days, we encourage you to set dimensions in order to avoid causing layout shifts in the page. You can drop loading equals lazy on those images in order to lazy load them. You have the ability to control asynchronous decoding. You can even set placeholders for image loading just using a background style. And you can decide whether to show a solid image color there, an inline SVG. But you have a lot of flexibility that we once didn't necessarily have in place. Now, I talked a little bit about the importance of images on the web, and there's a lot to this space from a science perspective. You just think about landing pages, product photos, feature panels, and so on. And there's a lot of thought that goes into making sure that often those experiences are as crisp and as good as possible. And this touches a little bit on neuroscience. So about 50% of the brain is involved in visual processing. It only takes a split second often for us to get a sense of a visual scene. We're able to recall about 80% of what we see, but only 20% of what we read. And so visuals start to become really important in these cases. Now, one thing I discovered as I was digging into neuroscience on the topic of images is that just mentioning cognitive neuroscience makes people more inclined to believe what they're reading. And so this slide has totally justified itself if you've believed anything that you've seen on it. Now, I mentioned that how we load images on the web can sometimes come in all sorts of shapes and sizes. And really, to be effective, all of these images need to be carefully orchestrated to appear on a screen fast. But as it turns out, loading images efficiently at scale isn't just a project for a quiet afternoon. There are quite a few different ways that you can approach this. all the way from just using the image tag in a very basic form, where sometimes we can cause this almost pop effect on the page once the image is loaded, going from something like a white area to that final presentation, all the way through to specifying a dominant color to give users a feeling of what they're likely to see, progressive image rendering, where you start to try portraying some idea of what the final image may look like. And there's this whole spectrum of ideas around blur hash or low quality image placeholders, whether you're using SVG for them or you're using a very low dimension version of your image in order to give people some predictability around what's going to be shown. But this is a really interesting topic. You can go very deep on it. But I just wanted to capture that there's a lot of nuance here in terms of the way that you solve for preventing flash, previewing content, or giving people a little bit of joy in the experience. Now, in my teams at Google, we focus a lot of our time on developer tooling. We're trying to make sure that not only can you measure the quality of an experience, but you also have very concrete guidance on how you can go about improving it. And so we're going to talk a little bit about tooling throughout the different tips and tricks that are covered in this presentation. Before we do that, I'm just going to talk very quickly about metrics. Now, these days, very often we'll talk about the Web Vitals, which are a set of metrics related to user-centric experiences on the web that have come from Google. Now, in many modern web experiences, images tend to be the largest visible element in the page as it's completing loading. And those include hero images, sometimes images from carousels, stories, banners. And the largest contentful paint, or LCP, is a core Web Vitals metric that measures when the largest contentful element, it's often images or text, is in a user's viewport, such as one of those images, and it becomes visible. Now, there are lots of things that impact LCP. It can be how soon the image is discovered and fetched by the browser. It can be compression. It can be other factors like image dimensions or DPR. There's a lot that goes into it. Now, I should also mention there are two other metrics on the screen here right now. We have cumulative layout shift, which is all about trying to capture the unexpected shifts or jank that can happen inside of a page, pushing content down. And first input delay, which is really about trying to reason about interaction readiness for a page and your ability to start tapping around the experience. Now, images can actually impact these things in different ways, and we'll talk about that in just a moment. Now, if you're following along the Web Vitals and you're interested in metrics, the Chrome Speed Metrics team actually try to maintain a pretty good changelog of ways they're trying to adapt largest contentful paint to account for modern content. One of their most recent changes was making sure that LCP ignored full viewport images. But if you're interested, I'll be sure to link folks up and you can check out the changelog later. Now, this is really the money slide. If you're interested in optimal image serving for Web Vitals, here are the things that I often try to do and that I generally recommend folks consider. Now, for a fast, largest contentful paint, try to request your key hero image as early on as possible. There are many ways that you can do this. Ideally, the browser is just able to discover it early on and you don't need to employ lots of other tricks. You can, however, rely on things like preloading to try making sure that other resources are not getting ahead of the queue for your largest contentful paint image. You can use picture, source set, and modern image formats to try squeezing as much value as possible out of something that's a slightly smaller file size. You can avoid wasting pixels. I've seen plenty of sites where they're serving either overly high DPR images, all the way up to, something that is probably never going to be fetched in some cases, perhaps, or some places where people are serving overly high DPR images that are so high that even if a user was pinch zooming and trying to go in, they wouldn't need something as large as what is being served down. And then you can also lazy load images. For a low cumulative layout shift, set dimensions on your images ideally, so your width and your height. If you're doing something much more elaborate, maybe something much more responsive, consider CSS aspect ratio or aspect ratio boxes to reserve that space otherwise. For a low impact on first input delay, just keep in mind that sometimes images can cause network contention for other critical resources, like your CSS or your JavaScript. Now, to identify the largest contentful paint and what image may be impacting that, There's an audit in Lighthouse that will try to identify what element was the LCP, and hovering over the element will highlight it in the main browser window. Now, I should note that while tools like Lighthouse are really good, they are limited in some ways. So Lighthouse will effectively look at load for about 60 seconds, whereas in reality, you might be building an experience where the image that is the hero may change for a variety of reasons. And so we try to recommend folks take a look at field data and run, and the LCP API can really help here. So it can help tease apart whether LCP is impacted by user devices that have different screen resolutions or different layouts, and just help you get a much more complete picture of what the LCP you need to optimize is. Recently, we've been seeing a lot of folks starting to play around with modern image formats and reporting, both decent-sized image savings. So both Tim and Oliver here noted significant image size decreases as a result of using AVIF. We've also started to see people begin to get LCP improvements if they're trying out AVIF compared to JPEG. And so experiment, try to see, do A/B testing and see just how far modern image formats can help you optimize your own LCP. Now, another thing that I wanted to mention was Lighthouse does have an audit that tries to identify if you could be serving images in next generation formats. We very recently updated this audit to estimate AVIF savings. And so if you're wondering just how much AVIF could potentially save you, take a look at the potential savings column and evaluate whether AVIF or WEBP might be worthwhile for your particular experience. Now, when it comes to serving modern image formats, you have a few different options available to you. Content negotiation using accept headers is something I mentioned earlier. For a lot of folks, you'll probably be using the picture tag. Now, the picture tag in art direction allows us to serve different images depending on a user's display. Now, while responsive images may load different sizes of the same image, and art direction can load very different images based on the display, we can also take advantage of this mechanism so that the browser can choose which image format to display using the picture element. So picture supports multiple source elements and a single image element. And you can reference lots of different formats here. In this example, the browser is going to begin parsing the sources, and it will stop once it's found the first supported match. If no match is found in your sources list, the browser is just going to load the specified image as a fallback. And so this is a really nice way of kind of either progressive enhancing your image loading experience or providing a graceful degradation back to a JPEG. But this approach has a lot of flexibility to it. Again, when it comes to picking an image format, there are lots of trade-offs. You might care a lot about photographic images. Some people may have things that are more illustration than raster images. You may care a lot more about animation support or wide gamut or progressive decoding. And so this chart here tries to provide a little bit of a breakdown. It's also in the blog post I recently shared around. But hopefully, consult tables like this, do your own research, and see just how well WebP or AVIF might meet your needs. Now, there are a few blog posts by colleagues, by people in the industry who are also really nerding out on image compression that you might find interesting. Malta Ubel from Google Search has got a great post looking at what quality settings to pick when you're generating AVIF and WebP images as alternatives to JPEG. And the goal of his blog post here is really to find the quality setting that is equivalent when you're trying to create images that look just as good as your original JPEG, but want a smaller size without necessarily sacrificing on your image quality. So I check out Malta's blog post. I think his website is Industrial Empathy. Another really good blog post by John Snares over at Cloudinary is about it being the time to dethrone the JPEG. And he goes into lots of different facets of how you should think about the trade-offs between different image formats, and talks about this idea of when lossy compression is good enough, AVIF can probably deliver better results than a lot of the existing codecs, in some cases including WebP. But many of the tables presented in that blog post are really, really insightful and provide a good granular breakdown of where certain features might be better supported in either emerging formats like JPEG XL or kind of modern formats like AVIF or WebP. Now, tooling is really important. One thing you'll notice throughout this is I am trying to use these stock photos of CMU as much as I can. I'm getting a lot out of them. So when it comes to image optimization tooling, if I'm doing just one-off image optimization, I'll very often use Squoosh. It supports a lot of bleeding edge formats, the ones that I talked about today, including, other experimental formats and formats that are still on the horizon, like JPEG XL or the next version of WEBP. And it offers a pretty low friction way to experiment with these ideas. I've also used things like ImageMin or ImageMagick or Sharp, depending on my use cases. There's a very large body of image optimization tooling out there that you can use. And these days, I love a lot of that tooling. If you can get away with just doing image optimization tooling as a part of your build step, that's awesome. Very often it's like a relatively affordable option too. The cost you're paying is in time. Sometimes you may be doing something where you need a lot more flexibility, or just paying that cost during build time isn't realistic for you because you may have just so many images. You may have thousands or hundreds of thousands of images. And this is a place where I personally rely on image CDNs to give me maximal flexibility. Now, image CDNs do often cost, but I personally like the flexibility they offer. So in this case, we have Cloudinary. We've got an image CDN that allows me to customize in their management UI what format I want served. So I can kind of select WebP. I can select JPEG 2000. I can select a format. And it will just give me a URL that I can drop into my pages. I can also customize the quality, the height, cropping, and so on. It gives me quite a lot of flexibility. It's also got this auto option at the very bottom. Now, if you don't really want to, have to think about what image format you want to be serving down to your users, this can be interesting. So in this case, if I select auto, I'm basically telling Cloudinary that I wanted to try picking the most appropriate format for me based on the user agent, based on what the browser supports. So I'm going to select auto here. Now, what happens is that I'm actually still just using the URL for my JPEG, but because I've selected auto, it's updated the URL to include that as a parameter. And Cloudinary now has the ability to automatically detect which browser is requesting the image and select the most efficient image format to deliver. So here we can see that although I've used JPEG as the extension, it's actually served down a WebP since Chrome supports WebP. This is all powered really by accept headers. Now, it's common for web clients to send an accept request header, and that indicates what content formats they're willing to accept in a response. And here you'll see, we've got AVIF listed, we've got WebP, we've got other image formats. And if the browser indicates in advance that it's going to accept the image or WebP format, the web server knows that it can safely send WebP images, greatly simplifying this overall content negotiation. There's a lot of other things that developer tooling gives us. So in DevTools, you're able to play around with with disabling modern image formats just to see what does the fallback experience look like for folks who may be on other browsers. So here, if we hit escape and we go to this particular panel, we're able to toggle on and off AVIF, JPEG XL, or WebP for testing them in the rendering panel. So you might get some value out of that. Now, I mentioned that Lighthouse tries to guide folks down this path of doing better, and it includes a number of image optimization audits for helping you understand if your images could be better compressed, or if they could be delivered in a more optimal modern image format. So properly sizing images is another thing that it tries to encourage you to do right. I see lots of cases where designers may be handing you a particular image that you need to be using in the site design or in the blog post, and folks will not necessarily realize that that's the full size image, whereas you may be showing something that's much, much smaller. And so it's very important to properly size it. Keep in mind DPR, keep in mind, people may be viewing it on a screen size that's different to the one that you're on right now. But overall, just ensure that you're not sending down overly sized images when possible. So I mentioned layout shifts earlier. What does that look like in practice? So here in this page, what we saw was that the images popped in and it actually pushed down the content because the browser didn't know how much space it should be reserving ahead of time. Now that's causing some layout shift. The way that we address that and limit cumulative layout shift is by making sure that we're setting dimensions on the width and height for our images and for our video elements. Now, this approach ensures that the browser is able to allocate the right amount of space in the document while the image is loading. And Lighthouse has an audit that will highlight images that don't have this width and height set. You can, of course, also take a look at your RUM data and try to debug from RUM. What are elements that are contributing to layout shift? Does one of these happen to be an image? But in general, just try to keep an eye on dimensions and setting dimensions width and height where possible. Now, to render an image on a page, it typically needs to be decoded and resized to fit in the layout. Depending on the size difference between what you're sending down, what is requested by the layout, what is the device screen size, and the CPU power available, this process can negatively impact rendering performance. And so serving images in the needed dimensions can shave off CPU usage. It can speed up the overall rendering time. There are lots of things that contribute to this overall picture. And just keep in mind that there are many factors that you might want to think about. Now, when it comes to switching image resolution, the standard image only allows us to supply a single source file to the browser. But with srcset and with sizes, this might be something that's very familiar to a lot of folks, so I'll try not to go too deep into it. We can provide many additional source images and hints so that the browser can pick the most appropriate one. And this allows us to supply images that are smaller or larger. The srcset attribute defines a set of images that the browser can select from, and it also identifies the size of those images. So each image string can be separated by a comma. It can include the source file name, a space, and then the image's intrinsic width specified in pixels, or a pixel density descriptor. So just keep in mind, you've got a little bit of flexibility there. And when it comes to srcset, width and height, again, this is kind of visualizing the differences between those width descriptors and those device pixel ratio descriptors. They look a little bit different and have a slightly different relationship, but just keep in mind this example. Now, DPR is something I've mentioned a few times. Device pixel ratio is DPR, and it really represents how a CSS pixel is translated to physical pixels on a hardware screen. Now, high resolution and retina screens use more physical pixels to represent CSS pixels for images that are sharper and have more detailed visuals. But there are cases where the human eye may not be capable of kind of distinguishing the difference between images that are 2x or 3x DPR or an even higher resolution. Now, serving overly high DPR images can be a common problem for sites that are leveraging srcset. And we've actually seen some large sites, Twitter is one good example, where they have limited image pixel density, in this case to 2x, and they noticed no distinguishable difference to the human eye in their tests, while allowing them to get a 33% decrease in image size. Now, this is an optimization worth considering. It's not something that's a default in many systems today, but I would test it out and see if it makes sense for your users. Image aspect ratio is another thing just to keep in mind. This has changed a little bit in recent years. The traditional way to reserve space for images was to use something called the vertical padding trick. And this is where you would, you'd have padding top set, you try to figure out this equation, and it was pretty complicated. The modern and simpler way to tackle this is defining a width and height aspect ratio. Defining a width and height, and then your aspect ratio is implicitly figured out through your width and height attributes on images and videos, and that's called the mapped aspect ratio. In the future, you'll also be able to explicitly set the aspect ratio in your CSS using the aspect ratio CSS rule. Now, another tip for dev tools, it now includes in the overall DOM tree view and elements an enhanced image preview. This shows you the file size, the rendered aspect ratio, the intrinsic size, as well as the intrinsic aspect ratio. This can be really, really important and useful if you're trying to figure out, well, on my desktop, what image was actually fetched? What was the size of the image fetched? What was the format fetched? And so all you need to do is hover over your image element, and this will pop up, and hopefully you'll get some value out of it. Mentioned lazy loading earlier on. Lighthouse also has an audit that will try to list any off-screen images or hidden images on a page that can be safely lazy loaded, as well as the potential savings from doing so. And the savings that you can get from image lazy loading can be quite large. There are off-screen images that maybe are not going to be visible until a user really scrolls down the page, And you may be introducing, contention with other resources. I've seen pages where they're not using lazy loading. It can fetch 5 to 10 megabytes worth of images that a user's not going to see until they scroll down. And those are generally good candidates for lazy loading, especially if you're targeting lower end devices or folks who are in emerging markets. That can be a nice optimization for optimizing their data plans. So just to reiterate, lazy loading images these days can be done using loading equals lazy. Just drop it on your image tag. This is also something supported on responsive images because it's really that image tag that's driving the overall loading experience. If you add loading equals lazy to that image tag, you should be all set. Now, another thing I wanted to remind folks of, this is something we recently wrote a web.dev blog post about, is that you should really only lazy load off-screen images. You don't want to lazy load stuff that is within the initial viewport. Doing so can, in some cases, cause an LCP regression. So just keep that in mind. This blog post goes into some of the data behind this recommendation. It's worth checking out. Speaking of loading, there are sometimes cases these days where you might be using React, Vue, Angular, or another JavaScript framework in order to build out the components for your experience. You may have lots of different kinds of delays that introduces into the overall picture, including your LCP image needing to wait for a lot of different JavaScript chunks or JavaScript bundles to be fetched and parsed before the browser can discover that image. Now, one thing that you can do to address this is using preloading. With preload, you can allow the browser to discover those critical resources like your LCP image as soon as possible prior to them being found in HTML, just so that it can be in the right place within the queue. Now, this can boost how soon those late discovered hero images that might be either loaded behind JavaScript, or maybe they're a background hero image that is defined in CSS and requires that CSS to be parsed and fetched. Like, it can make a meaningful difference in those cases. I should say you should always use preload sparingly. It is not a panacea. It's not going to automatically fix your issues just by dropping it on everything. So use it sparingly and use it very intentionally. Always test the impact that it has. Lighthouse has got a number of audits around preload. We've been adjusting this as recommendations around preload have been evolving. But in general, if you want to look at what preload effectively means and what it looks like, you would use the preload tag. You can specify the as type as image. You can specify the location of the image that you're trying to point folks to. And in general, you have flexibility to also be able to preload images that are part of your responsive images story too. For folks who are on the bleeding edge, we've been working on a proposal called Priority Hints for a few years now. And Pat Meenan has recently been taking a second look at this proposal. And priority hints effectively allow you to use the importance attribute on an element like images. And you can specify importance equals high, ideally in order to get your image loading much, much sooner. Now, you might be wondering, what's the difference between priority hints and preload? Now, with preload currently, preloaded images still get a relatively low priority in some cases. If it's preloaded early enough in the head, prior to asynchronous scripts, and it's loaded in the first part of the waterfall, maybe you won't see, as many improvements with hints. But if it's pushed back by other early low priority resources, it may help. So if you're interested in experimenting with priority hints, there is an upcoming Origin trial. They can help with not just, changing the priority for images, but you can also use them to tweak the priority for scripts, for late body scripts, and a number of other use cases. Now, blurry image placeholders and this idea of providing, progressive loading user experience benefits can be something that you can achieve today just using the image tag. So you can use that style, that inline style, once again, to either include inline SVG images, or you can use it to just provide a background placeholder. But the idea here is really that you can provide a range of different kinds of previews, whether it's a base64 encoded data URL with a low quality image placeholder, or an SVG image placeholder. And it just allows the user to get a quick preview of the image, even if they're on a slow network connection. Now, I know that we're going to be running into time soon, so I'll try to wrap things up. By now, you might be feeling a little bit under the water. There's a lot of optimizations that we've covered so far. So how are we trying to make this simpler? To start us off, I'm just going to show you once again a nice stock CMU image. There is a faster way. Over in Chrome, one thing we've been doing is partnering up with a number of JavaScript frameworks to try seeing if we can improve the defaults and components that are available to you for baking in a lot of these ideas for efficient image loading by default. Now, the Next.js image component is a pretty good example of this. With the Next.js image component, we've baked in support for automatic source sets for images, the ability to enforce sizing to prevent layout shift, automatic lazy loading, framework-specific asset prioritization, layout options, support for image CDNs, a number of different features here. And this can result in up to a 60% faster LCP and a 100% reduced CLS if you're using them effectively. Now, what does this look like? So imagine that you have got a React experience using Next.js where you've just included a couple of normal images. You might be specifying, height this way and width using, something very similar to the normal image tag. And the way that this probably currently works in a create next app by default is that you're eagerly loading all of these images. So note that I'm in DevTools right now in the network panel. I've selected the image filter, and we're loading about 8.4 megabytes worth of images here. This is just 3 images, just 8.4 megabytes. And they all load regardless of whether the user can see them or not. And they're probably not as optimized as they could be. Now, this is what it looks like with the Next.js image component. We've imported in the image component into the page, and we've just replaced that lowercase image with the full word image for our component name, specified height and width. And now let's take a look at what the network timeline looks like after. We can reload our page and take a look at the DevTools network panel. Now only one image, this one at the very bottom, the donut, is the one that's being loaded by default because it's the only one visible in the viewport, and it's significantly smaller than the original. So it's 33 kilobytes versus 325 kilobytes. And it uses a more modern image format, so WEBP in this case. Now, when a user scrolls down the page, the additional images get loaded in lazily. The component just did the right thing by default. Now, the performance optimizations offered by the Next.js image component can really help improve largest contentful paint. We're excited about bringing these ideas to other frameworks. We're seeing good progress in places like Next.js, if you're a Vue.js user, working on a similar problem space with the Angular team. And if you're working on if you're working with a static site builder at the moment, like Eleventy, there are also options available for you to be able to take advantage of this kind of optimization. Now, to round us up, 2 thoughts. The first is that if you're working in a team at a business, very often the best optimizations are the ones that both improve user experience and business outcomes. Now, there are a number of case studies that we've seen over the last year where folks have been investing in trying to improve their largest contentful paint and their image experience. Vodafone is just one example where improvements in LCP were able to heavily increase their sales by 8%. But we've seen a range of other partners and other sites also see similar wins on their business metrics as a result of optimizing their images and optimizing their LCP and their CLS. My final thought, automate best practices when you can. Whether it's via a build process, an image CDN, or an image component, even if you know what you're doing, your team members might not. And so automation can be a really nice way to fire, forget, and just get it right. I hope that you got something out of this talk. And if it's useful, go check out the image optimization book from Smashing Magazine. So that's it for me. Thank you very much.
All right, thank you very much, Eddie. It's always a pleasure listening to you. It seemed like, I don't know, maybe it's just me, but I felt like 10 years ago, we just plug in an image tag and call it a day. Now, we probably need to write an entire book about images alone. This is how complicated, I guess, the web has become. Well, thank you so much, Eddie. Now,